and welcome back to the STEM Tutor. Today, we're going to be learning how to find the equation of a perpendicular line to another given line, which passes through a specific point. So your first step is look at the equation that's given to you. This equation is what we need to draw a perpendicular line to. Let's say each of these lines is 1. The equation of a line usually looks like this. So this example is 2x plus 1, but it's usually mx plus b, where m is the slope and b is the y-intercept. The y-intercept is just where your line crosses on the y-axis, which is always this last number here. That is our b value, which is our y-intercept. We are passing through 1 on the y-axis, which makes this point 0, 1. X is always the first number, which is always 0 for a y-intercept, and y is the second number. This is an xy coordinate. Now the slope is rise over run. So this is a 2, which means rise over run. There's an invisible 1 underneath the 2, so it's 2 over 1. You go up by 2 and to the right by 1. So let's graph this. Start here, go up by 2 and to the right by 1, up by 2 and to the right by 1. Your graph will look something like this. This is the graph of y equals 2x plus 1. We want to find the equation of a line that's perpendicular. And what would that look like? Let's find where the point 5, 4 is. It'll be 5 to the right and 4 up, somewhere here. If I draw a perpendicular line to the green line, perpendicular means it intersects at a right angle. So it will look something like this. Or basically anywhere that it intersects, that green line makes a right angle. That means perpendicular. And it continues on forever, so you can put the arrowheads, but we need to find the equation of this pink line. And remember, the equation of a line is usually in the form y equals mx plus b. If I extend this graph and you keep it going, eventually your pink line will cross the y-axis, and this would be your y-intercept, which is going to be the same as your b value. We don't know what that number is, but we will find it later. So how do we get the equation of the pink graph? We would be kind of lost if we didn't have any information to go off of other than just a random point that it crosses through. There's a key rule that you have to know when writing out the equation of a perpendicular line to a given line. And that rule is perpendicular lines have negative reciprocal slopes. If you watched the last video, we did a similar example but talking about parallel line equations, where parallel lines have the same slope. With perpendicular lines, their slopes would be negative reciprocals. The equation of our green line was 2x plus 1, and the slope that we got from that was that number in front of the x, which was the m value, and that was 2. Now take this number and flip the sign. So if it's already a negative, you're going to make it positive, and if it's positive, in our case, positive 2, you'll make it a negative. That takes care of the negative part. What about reciprocal? Reciprocal means it's flipped. So in this case, what does that mean to flip negative 2? If it's a whole number, just like I showed here, negative 2 or positive 2 would actually have an invisible 1 underneath, but it's not shown. So you can draw that in and then just flip it. So the reciprocal of negative 2, or negative 2 over 1, would be negative 1/2. It doesn't really matter where the negative goes. You can keep it out front, or you can just keep it on top. It means the same thing here. But this would be the slope of your perpendicular line, which means your answer would be something like this. This is the m value, and now we can find b. We know that a point on the graph is 5, 4, so we can actually plug that in because this is a coordinate point. The first number is always x, the second number is always y. So if y is equal to 4, and x is equal to 5, you can plug those numbers in and just do order of operations to solve it. It's negative 1/2 times 5 plus b. You have to multiply these first, and when you multiply a whole number by a fraction, it is easier to just make the whole number look like a fraction. That's what I like to do. So remember, if it's a positive 5, there is an invisible 1 underneath. So I'm going to write it like this, and when we multiply fractions, we always multiply across the top and across the bottom. So this becomes -1 times 5, which is -5 over 2 times 1. Now we have to solve for b. Because this is a fraction, but this is not, we will need to add and subtract them. So I'm going to make the 4, again, a whole number, shown with that invisible 1 underneath. And let's move this to the other side so we can add it. Because this is a negative fraction, when we move numbers to the other side of an equal sign, we do the opposite operation. Because this is negative, which indicates subtraction, you're going to make it a positive, so it becomes 4 over 1 plus 5 over 2. Recall, when we add fractions, you do want a common denominator. You usually take the smaller of the two numbers on the denominator. In this case, we have a 1. We want to multiply this by 2, so it's the same number as this, which means we need to do the same thing to the top. And we get 8 over 2, which is the same as saying 4 over 1. But now it can actually be added to 5 over 2. And when we add fractions, we just add the top, which is 13, and keep the bottom the same. So your b value is now 13 over 2. That means your final equation would be -1/2 x, which was your m value, plus 13 over 2, and this was your b value. And that would be the final answer. Thank you for watching.